welcome back to Math 9. Today we are going to be beginning the next chapter, which is chapter 4, linear relations. Now, this unit kind of really goes into our chapter 6, where we're going to continue to be doing this. And you will find that a lot of what we are doing in this section are things that we have done in the past, and we're just going to be taking things one step further than before. So because of this fact, it is very important that we review some of the things that you will have previously seen. So at the end of this unit, you should be able to generalize a pattern arising from a problem-solving context using a linear equation. You should be able to verify by substitution, and you should graph a linear relation and analyze the graph, as well as interpolate and extrapolate to solve problems. So if there's any of these words that you still don't know, that is okay. We're going to be learning them as we go in this unit. So if we do some review from previous years, you would have seen these. I believe in grade 6, they're normally like the exit entrant robots kind of process. And we just kind of look at the input output and what do we get and what is something that consistently happens every time. So you can look at patterns, but when it's asking you what's the rule, it's asking you the relationship between the x and the y. So if you want to pause and take a minute to look through and see if you can figure it out, feel free to pause me. If you are ready, you can press play. So when I'm looking for the rule, you often need to look at a pattern to help find the rule. Now, because it goes up 1, 2, and up 5, 6, and then 5, 6, 7, you can kind of see that it's only going up by 1, and it's not a different thing. So it's probably just a one-step equation. So I need to ask myself, what do I do to the 1 to end up at 5? So I can say 1 times 5 is 5, but 2 times 5 is not 6. I could say 1 plus 4 is 5, and I could see 2 plus 4 is also 6. 3 plus 4 is 7, 4 plus 4 is 8, and 10 plus 4 is 14. So I know that each time to go from x to y, I am simply adding 4. If I look at the second example, 1 to get to 0 would be like minus 1, but 2 goes, minus 1 does not give me 3, it would give me 1, so I can't just subtract. I can multiply by 0, but that doesn't work. I could try a division, but that doesn't work. So because of these things, I know that it has to be a more than one-step process. So oftentimes when we are looking at multiple steps, using the pattern in our y column will also help us get started. So if I'm looking at the pattern in this y column, it goes up by 3 and by 3 again. So I'm going to see if I can try an equation that uses 3. So normally that is going to be either multiplied by our x or divided by it. So if I say 1 times 3, I'm at 3. From there, how do I get to 0? I would have to subtract 3. If I tried the exact same process in the second example, 2 times 3 would be 6, and 6 minus 3 is 3. For the third example, 3 times 3 is 9, and 9 minus 3 is 6. So you can see that it is happening every time. So 4 times 3 is 12, and 12 minus 3 is 9. And we got 5 and 12, so then it's asking what could x be if y is 27. So if my equation, and this is what it actually looks like written out, is this: to figure out the x when I know the y is to work backwards. So to get to the 27, I have to subtract 3, so I'm going to add 3 to give me 30. And then I'm going to say 30 divided by 3, which gives me 10. Now if I look at the very last example, this one's a little bit more of a challenge. You can see that I do not have a set pattern in my y column. It's not going up by 1 each time, but it's not even counting by the same amount. It's going up by 3, by 5, by 7, by 9. So there's a clear pattern, but that doesn't necessarily help me figure out the relationship between the two. So it is a two-step equation, But if I looked at it, 1 times 1 is 1 plus 1 is 2. If I tried 2 times 2 plus 1 is 5. 3 times 3 plus 1 is 10. 4 times 4, 16, plus 1 is 17. So what I'm doing each time is I'm multiplying the x by itself. 6 times 6 is 36. And then I'm adding 1. Okay, so if I'm going to write that, I'm actually just squaring my x and then adding 1. So in a question like this, it may take a couple extra steps in order to solve it. Similar review that you will have seen in previous years, they may give you an image and ask you to create an equation based on the pictures. Now, before you can create an equation, you often have to create a table of value to make it a little bit easier to see. So I'm going to say that in my table, I'm going to go with, this is the figure number, and this is how many blocks in each of them. So in the figure one, I have 2 blocks. In the second one, I have 1, 2, 3, 4, 5, 6 blocks. And in the third, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks. Okay? Now I need to figure out what I am doing each time to get an equation. So if I'm looking at a pattern, again, this goes up by 4, and now this is going up by 6. And I need to figure out what pattern am I using? How can I go to each shape? What is being different? So again, because it's not clear, you may have to do a little bit more work. So 1 to get to 2, I could say 1 times 1 plus 1 is 2. 2 times 2 plus 1 is not 6, but if I said 2 times 2 plus 2, it could get 6. 3 times 3 plus 3 would equal 12. So what I'm actually doing is I am squaring my figure number, and then I'm also adding that figure number to determine the amount of blocks that I am using. Okay, so this one, another one that actually challenges and pushes us a little bit more. You'll probably be happy to know that there is not a lot that you need to figure out the rule for in this. It's going to be more questions like, which table of values does this rule actually apply to? Okay, so they're going to ask it a little bit different to help alleviate some of our stress of trying to figure out what's happening. There is one third example. This one, instead of asking what's the rule, simply asks you what's the pattern. So it's really important that you're paying attention to the vocabulary that they're asking. Otherwise, you may be spending a lot of time on a question where you don't have to. So this just wants to know what is happening each time. So again, start by making yourself a table of values. So in shape 1, 2, and 3, and I'm going to just say that these are sticks. So in this, I have 1, 2, 3, 4, 5, 6 sticks. In figure 2, I have 6, 7, 8, 9, 10, 11. And then I had 11, 12, 13, 14, 15, 16. So if I'm asking you what the pattern is, I am not asking you for the rule. I'm asking what is happening each time. So in that kind of situation, you'd be saying each time that you add another figure number, you are adding 5 more sticks to complete the pattern. Okay, you may know that your formula is 5 times the figure number plus 1 to get the sticks. Okay, but it was just asking you for the pattern. Other stuff that you need to remember how to do in this section from previous grades is to solve some algebraic equations. Now, I know that there's a lot of different ways in which we can solve algebraic equations, and some of them you may be able to look at and just know the answer to. And that is okay sometimes, but it's also important for you to understand the steps that you need to complete in order to solve them to make it as easy as possible. So if I'm looking at this first one, n plus 6 equals to 10, you're just asking what plus 6 is equal to 10. And you may be able to just tell me that answer is 4. Now, if I asked you to solve it with algebra, you would be showing how to do this by showing the steps. And the steps are showing the opposite order of operations. So I start with the adding and subtracting, and I do the opposite. So the opposite of plus 6 is minus 6. And what I do to one side of the equation, I have to do to the other, which gives me n equals to 4. Okay, for question 2, what number plus 3 is equal to 5? Again, you may be able to just know this at the top of your head and say that 5 plus 3 is equal to 8. But if I ask you to show me how this can be solved by using algebra, again, you are showing me using opposite operations. The opposite of plus 3 is minus 3. What I do to one side, I do to the other. And this is why 5 is equal to n. Question 3, 14 plus 7, 21. Question 4, if you have something on both sides of the equal, you actually have to solve the side that you can solve before you're going to keep going. So 48 plus 7 is actually equal to 55. So 15 plus n is equal to 55. What number are we missing? So we can use algebra and subtract 15 from each side, which gives us an answer of 40. If I look at 5, it's the same thing, but in the reverse order. Know that your steps are still the same. If you can solve the side, you should solve it. So 6 plus 14 is 20. 20 is equal to a number plus 8. So what do I need to add to 8? So I can solve using algebra. The opposite of plus 8 is minus 8. What I do to one side, I will do to the other, which gives me n equals 12. And very last question, I am going to simplify what I can. 200 plus a number is equal to 460. So the opposite is to subtract by 200 from each side, which means that n is equal to 260. Okay, so if you're not sure how to solve algebraic equations with opposite operations, please let me know. I can provide extra videos or extra worksheets and practice that you can go through, or if we need to meet one-on-one, we can do that as well. Similar, except for now where we're looking at subtraction instead of an addition, the steps are almost the same, though sometimes we need to move things around. So if I have 62, what do I need to subtract from it to equal 56? Okay, so to get from 56 to 62, it's still like an addition, so I'm just missing 6 in order to do that. If I want to solve this with algebra, I'm kind of moving things around, and I can replace, like if I had 12 minus 3 is equal to 9, I should know that 12 minus 9 is also equal to 3. So I can trade around my last two digits and still get the same thing. Okay, so if you need to move stuff around like that, you're free to do that. For the second one, 48 minus 12 is pretty straightforward because it's all on one side and is equal to 36. Something minus 14 is 23. Again, when it's written like this, it's easiest to solve using algebra with opposite operations. So the opposite of subtracting 14 from both sides would be adding 14, which means that n is equal to 37. Question 4, if I can simplify a side, I should be doing that. 18 minus n is equal to 8, and I can trade out the n in the 8 places. So 18 minus 8 is actually equal to 10. 65 minus 31, because it's all on one side, I can just simplify. Gives me 34. And 34 is equal to something minus 12. So the opposite of minus 12 is adding 12. What I do to one side, I do to the other. So n is equal to 46. And the last one, I'm going to say 45 minus 12 because it's all on one side of the equation, which gives me 33. And that's equal to 50 minus something. So when it's 50 minus that, I can trade off my n and 33 and say 50 minus 33, which gives me 17. Okay, again, with algebra, the more you do it, the more it sticks and the easier it becomes. Some practice with multiplication. So I have it written out like this, but you will often see it written out differently with the number next to the variable instead of having them have that time symbol in between them. They often do that so that you are not confused, thinking that there is more variables than there actually is. So don't be confused if it's written like this instead. You just need to recognize that that does mean multiply, and the opposite of multiplying is dividing. So in order to solve an equation like this, the opposite of timesing it by 2 would be dividing by 2, and what I do to one side, I'm doing to the other, so n is equal to 6. If I do the same thing for the second one, the opposite of multiplying by 6 is dividing by 6. So 42 divided by 6 is actually equal to 7. For the third one, as my multiplication's all on one side, that's just a regular equation. 10 times 30, n is equal to 300. N times 6 is equal to 3 times 8. So I'm going to start by simplifying the side that I had both answers to. So 3 times 8 is 24. So n times 6 is 24. The opposite of multiplying by 6 is dividing by 6. What I do to one side, I do to the other. N is equal to 4. 12 times 5 on the same side of the equation is equal to 60. The opposite of multiplying by 3 is actually dividing by 3. So 60 divided by 3 is actually equal to 20. And the last one, 8 times 5 is 40. And that is equal to 10 times n. The opposite of multiplying by 10 is dividing by 10. And what I do to one side, I do to the other. 4 is equal to n. Last section to review is division. Division in the same steps. We can do things one at a time. And the easiest way to solve algebraic equations is by working with opposites. So the opposite of dividing by 4 is actually multiplying by 4. What I do to one side, I'm going to do to the other. So n is equal to 28. 32 divided by a number is equal to 16. When it is written like this, we are remembering that I can just trade out the n and the 16. So 32 divided by 16 is the answer for n. So n is actually equal to 2. For 3, that's just a regular equation. 12 divided by 4, n is equal to 3. When I have steps on two sides, I'm going to solve the one that I can. 6 divided by 3 is 2. So n divided by 5 is 2. Opposite of dividing by 5 times 5 times 5. So n is equal to 10. 36 divided by 9 is 4. 24 divided by n is equal to 4. When it's written like this, I can trade out the 4 and the n. So 24 divided by 4 is actually equal to 6. And the last one, 8 divided by 4 is 2. The opposite of dividing by 3 is multiplying by 3. 2 times 3 is 6. I hope that solving the algebraic equations makes sense for you. Again, if you are stuck on anything or need extra review, please make sure you are letting me know. Calculate the value of b in each equation. So we've also worked a little bit with this, and this is just substitution. So they're going to give you an equation and tell you the value of one of your variables, your letters, one of your unknowns, and ask you to solve it. So b equals 4n when n is equal to 9. So what that actually means is that b is equal to 4 multiplied by 9. So b is equal to 36. For the second one, 3n plus 4 is equal to b. I'm replacing the n with 12. And 3n, that means multiply. So 3 times 12 plus 4 is equal to b. 3 times 12 is 36. And 36 plus 4 is 40. For question 3, b equals 4 minus 3n. So you're going to replace your n with 6 in this case. So b is equal to 4 minus 3 times 6, which is 4 minus 18. So you're working with some negatives as well. So b is actually equal to negative 14. Question 4, 2n divided by 9 is equal to b. So when it's written like a fraction, that just means it's a division. So I'm replacing the n with 27. So 2 times 27 is actually equal to 54. And 54 divided by 9 is actually equal to 6. And the last one, 24 divided by n is equal to b. This one is not an even number, so you're just replacing your n with a 9. So 24 divided by 9, and that actually gives you an answer of 2.6 repeating. So a lot of the questions you're going to be seeing are going to look kind of nice, but because we have already covered rational numbers, not everything is necessarily going to have a nice, clear answer, and some of them might look a little more complicated, like this last one. So that brings us to the end of the review and things that you need to know to begin this next section. At this point, if there's any questions, please make sure you're letting me know. Have a great day.